Hello, everybody. Thank you very much for coming all the way over to Mandalay Bay to hear me talk about logs. Now, this presentation partly is a story about what's really possible with AI. And this picture here was actually generated by Sora. It's actually me at the 1966 World Cup, which I am far too young to have been a part of. Witnessing England's winning goal, which is the only time we've ever seen success in a sport we invented, right? So, right. So let's talk a little bit about the problem that people are experiencing today. Observability today has been laid down with a foundation of data collection, proprietary agents, and in a lot of ways, we've come to rely on dashboards and visualizations, but we're struggling to get answers. And we have a lot of alerts out there today also without context, right? So, I get an alert about some CPU usage issue on one of my boxes, or my Kubernetes cluster pods are running out of memory. I get the alert, I just don't have a lot of context. I don't know what to do with it. And this is a challenge that we see our customers struggle with every day. And even when, you're looking at the outcomes, a lot of time is spent working on putting together the data pipelines. Just to get the data into the observability solution, you have to create lots of log pipelines. Maybe you use Logstash or something like that. And it takes a lot of work. And a lot of data gets lost during this process. So I talk to customers all the time, and they say to me things like, half of the logs that I'm trying to get into my solution here are just being dropped on the floor. And if you don't have the information, then you spend a lot of time wrestling with getting answers to the problems that you have, which increases the amount of downtime. Customers are experiencing slow systems. I was trying to get onto Claude earlier today, actually, and it was currently down. So, what do we do while customers are suffering with these problems, right? We need to get things up and running again and get people back online. And part of the problem here is the why has been missing. I was an SRE a long time ago, and I used to work with logs on a regular basis to figure out what's wrong with my systems. And back in those days, we only had 5 or 6 different servers, and I had a notepad file with a list of grep and sed patterns that we'd come up with together as a team. I'd copy and paste those into my terminal and try to find the logs that way. And then over time, we built systems that became very, very complex, right? Microservices everywhere, Kubernetes everything. We've basically built enormously complex systems. And as a result of that, the industry has been telling you to throw your logs away, turn them into metrics, or put all that information into traces. But you can't rely on that, right? Because you can't instrument everything with traces. I think I looked the other day at a survey that an observability vendor had put out there. You can get to 50 or 60% of traces deployed out in your environment. What do you do with the rest of it? So we shouldn't be throwing away all this log data. We should just be being more intentional and more intelligent about it. So why aren't SREs using logs more? Because there's some great information in there. And like I said, every time I've solved a problem, it usually has come down to the logs. Well, they're messy and unstructured, right? So, the information in there is sometimes a little bit messy. Sometimes you can't do analytics on that data because it's unstructured. You have to parse it first, which goes back to the pipeline problem I was talking about. You need to write all these grok expressions or regular expressions. I actually did a search and looked up like what was the most complicated regex expression. And the first result on Google is somebody trying to use regex to parse a log line, right? Which I thought was pretty funny. And there's a lot of logs, right? Millions of logs or more. It's voluminous, the most voluminous observability signal that we have. And finally, there's all sorts of logs from all over the place, different systems, and that problem has gotten a lot worse. Again, when I was doing the SRE role about 10 years ago, things were starting to get very complicated, but we still had a manageable number of systems. We didn't have like a million different AWS services, for example, sending us data. All these different SaaS applications that we have now. It was kind of manageable. And every single system out there has a different format. And it's a shame that we can't rely on logs more because it's easy to collect logs. Even SaaS applications typically output logs. So you can get logs from just about everywhere. Even mainframes put out logs, ATM machines, everything emits a log. And logs typically have a lot of great context. They were written for humans to consume, typically. And so, things like user IDs, explanations, you can read them. They're like a novel in some ways, right? You can actually read logs if they're well written, of course. And you can get a lot of really good information, like you can see on the screen here, the server restarted, a host, for example. Well, what's needed to manage logs well? Well, first of all, you need a scalable platform because we've got a lot of logs out there. And you need a platform that can handle all of that at scale, right? So, if you want to write a query or you've got a dashboard, you want to be able to have those things updating quickly. You don't want to have to wait for hours and hours to get the results that you need when you're trying to solve a problem. And you need to be able to store this stuff fairly cost effectively. If you want to keep all your log data, instead of throwing it away, it needs to be in a way that's cost effective. And so that's what you need on the platform side. On the other side, we can use AI-driven analysis to extract incredible insights from logs. And we'll talk a little bit more about that later on. But first of all, let's talk a little bit about what Elastic does well already today. We have a lot of integrations out there in Elastic, so we can, consume logs from a huge variety of different sources. The platform is very, very scalable. Customers tell me all the time that they moved to Elastic or they adopted Elastic, and they were very, very impressed with the performance of the platform. They can get queries back in half the time that they could before. They can get information on their dashboards, and they can actually see the information quickly without having to wait hours for the dashboards to load. Elastic does these things very, very well. And we also have good ML-driven pattern analysis, classic ML algorithms, anomaly detection, pattern analysis, things like that. We can do really great search and filter things. We have this new query language called ESQL. If you haven't seen it already, check it out. We keep adding stuff to that all the time. We just GA joins, which is great. So now you can join data in Elastic with ESQL. And we keep adding ML functions to ESQL as well, which is great. So you can actually query a lot of data in Elastic now, and inside the query language, you can send the result to an LLM and get it to have a look at what the issue is from the ESQL query directly using the piped query language. You just pipe it to the LLM, have the LLM do the analysis, and it comes right back into your results. Really fantastic. So ESQL has some very, very powerful analytic capabilities. So how do we store log data efficiently? We recently released logsdb index mode, and the way it works is it does, one of the main ways that it works is that we do some additional compression on logs. We use index sorting. We also use a technique called synthetic source. So now we're actually storing logs in a columnar data format. We can save a lot of disk space this way. In fact, many of our customers are seeing up to 70% of their data storage costs have gone down using logsdb. And so, that's one way we're making it so that customers can store all their logs without having to throw them away. And we're going even further than that. We haven't actually released this particular part of Elastic yet, but we're currently working on a compressed log processor as well. So if you've got repeated log lines, like you can see in the slide here, we'll template those, right? So we only store the bit of the log line that changes. So we can save you another 50% in storage using this technique. And this is completely transparent to you. It's just happening in the background. So we have a great platform. You can store all your logs. You can, manually analyze the data really nicely with a lot of the analytic functions that we provide. If we take all of that power and we bring LLMs into the picture, we can do a lot more. We can do some really great things with all this log data that you have. That means that you don't have to go hunting and pecking. You get the insights delivered to you. And if we do that and give you those actionable capabilities, rather than just having to trawl through all this data, you actually get insights that you can action on, then we've actually created something magical for you, right? So we already talked about how we store the data efficiently. Once we have the data stored efficiently in Elastic, the first thing we do with this new AI-powered log analytics engine that we're calling Streams is we identify the systems. So we send the logs into Elastic, store them efficiently, and then the first thing we do is we look at those logs with the assistance of an LLM to understand what systems they come from. And you may have tried this yourself. I've certainly tried it myself, and it works phenomenally well, which is take a log line, chuck it into an LLM. Quite often, the LLM will be able to tell you where that log came from, what system it came from. It'll do some really good analysis on the logs, might even help you with the root cause. So we can usually tell, just by looking at the logs or a sample of the logs, not just one log line, but we get a sample of the logs, we can tell what system it comes from, right? So we can identify if it's Elasticsearch or Nginx, per this example. Once we've identified what system it comes from, we can then start to partition them automatically. So we can send Hadoop logs, for example, into a special Hadoop index. We can send Spark logs to a special Spark index. Or if you have Java applications and you've got an order processing service, we identify that it's an order processing service, and we send those logs into an order processing index. So now we've got your logs organized, and this all happens automatically. You can see here an example of how we organize that data. So it's not just going, one level deep, like I described here. You can go multiple levels down. So if you've identified an order processing system, you might want to separate error logs from info logs, for example, or you may want to go higher up. You might want to bucket everything under Kubernetes and the things that are under. So we have a hierarchical organization system here in play that enables you to organize your logs how you see fit. And like I said, using AI assistance to help you. So once we've got the systems, we've identified those, we've partitioned the data into sensible streams, we then want to extract meaning from your logs. So like at the moment, most people are still using unstructured logs, right? I would say a good 90% of the logs I'm still seeing out there are completely unstructured. And that is not good for analytics, right? So the next thing you want to do is take that unstructured data and structure it. So that's the next thing that we want to do with our data processing pipeline. Once we've finally done all of that, we've actually processed your logs, structured them, made it easy for analytics. The next thing we look for is any significant events. So like I said, we know if it's an order processing service, we maybe know if it's hosted on Kubernetes, we might know if it's a Spark system, whatever it happens to be. What we then do is, with the assistance again of an LLM, we say, what kinds of problems am I likely to encounter with this particular system? And here are some samples of some logs as well, so it gets familiar with what it's dealing with. And it will come back and say, you know what? This is a Spark system. There might be out-of-memory errors that you're likely to encounter. And what it does then is it generates a query that runs on a regular basis to see if there are any new occurrences of, say, this out-of-memory error. Now, you don't have to do any of this manually, right? This is AI doing a lot of the work for you. And then we can generate assets. We can generate dashboards. We can generate SLOs. We can generate things like visualizations. And we can even do things like put information about the systems that we've detected into our knowledge base. So if you don't know about this already, Elastic has a vector database in it, right? It's one of the big things that Elastic does. And all of our AI technology in the Elastic Observability platform is built on top of Elasticsearch capabilities like the vector database. And so we have this thing we talk about on a regular basis here at Elastic called retrieval augmented generation. So what we can do is if we have the AI analyze your systems, we can say, this is a Spark system. These are the things you need to think about with Spark systems. We can put that into the knowledge base. And so when you're dealing with problems within the AI assistant, having natural language conversations about your problems, what is the root cause of this problem and that, it can then refer to any information that it's recorded about the systems that it's working with, which will help you accelerate root cause analysis, right? And this is what it looks like end to end. Now, there's a couple of things that are interesting on this slide. Firstly, if you look at the bottom left-hand corner on this slide, we still support all the existing Elastic things like integrations that we have. If you're using Elastic Agent or Logstash or whatever, we still support all of those ingest mechanisms with this new Streams product. You can still use those. But naturally, those, when we send data in using an integration, we don't need to partition that data because the integration already tells it where to go in Elastic and organizes that data for you. So it skips the partitioning step. That's kind of like the legacy approach. We'll still support that. The new approach that we're pushing over here at Elastic is to send your data in using whatever you like. It could be the vanilla OTel collector. It could be Fluent Bit. It could be, whatever it is you're using today. It doesn't have to be Elastic technology. You can send it into our new logs endpoint, and we just put the logs in Elastic. You don't have to do any edge processing anymore. Move all of that over to Elastic. Send all the data to the log stream, and then we figure it out by starting out with partitioning. So that's Elastic Streams. Now, you'll see when I show you the demo, which I'm going to do in a minute, that it is like a magical experience. So let's do that. Let's switch over to the demo, and I'll show you what Elastic Streams looks like. So here we go. This is Discover, and I've got an ESQL query here. And this is log data, going back to the previous diagram that you just saw, that's coming in via the classic Elastic agent route, okay? And the first thing you'll notice about this data is that it's completely unstructured, okay? So it's just raw, unstructured log data, which is what most of you are probably dealing with today. At the moment, you could probably recognize a little bit about this data. It looks like trading data. And what we want to do is we want to structure this data. So we're going to click this little button here, parse content in streams. And the first thing we're going to do is we're going to create a new processor. Now, as you can see here, we have this handy little button here called generate pattern, and it has that little AI logo that you're probably seeing all over the place now. But if we click that button, you'll see that it generates a grok pattern for us, so you don't have to do it manually anymore, right? And you can see that it's like looked at the data, and it's got some understanding of the data, right? So it knows that this is a stock symbol and a quantity and a price, and it inferred this. We didn't tell it any of that information. We just gave it the raw logs that you see here. So if we accept that, now the data is going to be much easier to do analytics on, right? We can now start to look at how much did a particular stock trade for over a 30-day window or something like that, which would have been much harder to do had we left this data in an unstructured format. So let's save that. One thing you'll notice here that's very interesting as well is this little source thing here that says open telemetry. So when we do this with the generating of the patterns, we try to use open telemetry semantic conventions. So we're using this open standard schema. We store that in that standard schema format natively in Elastic, so you can be sure that all your data is being written in a standard format. We'll confirm those changes. And now, if we go back to Discover, we can now have a look and see how easy it is to run analytics on that data, right? So now we can actually do a sum of the quantities over the cloud regions. We can see that our workloads are pretty evenly split between all the different cloud regions that we have there. And we can do, other types of analytics now, because we couldn't have done that on the unstructured data, not very easily. Or you would have had to have manually created a processing pipeline to deal with it, right? So now we looked at how you do it with the standard processing pipeline using Elastic Agent and all that sort of thing, right? Now we're going to look at how you do it with in the new way, which is just sending your data to the Elastic log index. So this is a new special index called logs, and we manage all the complexity behind the scenes, like the ingest pipelines and things like that. You don't have to worry about those. We manage it. So let's take a look at what we want to do with that first. So the first thing we would do with that is partition the data. So we're going to go into partitioning here. And of course, we can still do things manually. We don't always have to use AI, right? We want to give you that flexibility. The AI isn't always going to get it right. And so we'll create a partition manually first. We'll call it Spark. We're going to use a field attribute to split off Spark logs from the log stream. So if we save that, what's going to happen now is you can see this hierarchy appearing where we've got logs at the top level, which is where we're just sending all our data. And now we've got a new index that's being written to, which is going to contain just Spark logs. But we can also do this with AI. So we click Suggest Partitions with AI, and AI would have done a perfectly fine job. In fact, we had Hadoop and Spark logs in the log stream, and it has split those out perfectly. So we're going to just save those changes. And you can see here that we have Spark and Hadoop logs, and you can see that hierarchy that I talked about before. So the log stream has now been split into two. We've got Hadoop logs and Spark logs separate from how they were. So once they're all separated out, we can then also do the same processing that we did before on those logs. We can create a processor, we can use AI to generate those grep patterns, and we can split out the severity text using that, and again, do a better job of analytics on this data. So let's confirm those changes, and then you'll see here, now I can run ESQL against that data much, much easier. Right, so what have we done so far? So we partitioned our logs, we structured our logs, we've ran analytics on our logs. The next thing that we wanted to do, if you go back to thinking about the diagram I showed you, is we want to find problems in our logs, right? So let's take a look at the Spark logs. And the first thing we'll do here is we'll detect what systems are here. We know it's a Spark system, but what the AI has done in the background is it's added additional information about the Spark system. So you can see that description field. It's kind of cut off at the moment, but it's got a large description about Spark systems and what Spark systems do and what types of problems that you might encounter with Spark systems. So once we've got we've identified the system and we've described the system to Elastic, we'll add that to streams, and we'll generate suggestions on the types of problems that can occur with Spark systems. So you can see this list here. We've got Spark debug events, Spark warnings, Spark out-of-memory exceptions. These are all things that are specific problems to Spark systems that might occur. And by bringing them into Elastic, we then keep track to see if any of these problems occur over time. We're actually using a technique called change point detection, which is a machine learning technique. It will detect whether there is a spike in the number of these logs over time, or if there's a dip in the number of these logs, or if there's a change in the distribution in these logs. It'll detect all of these things, and you can get alerted to those problems. And I'll show you how to do that. So here what we do is we actually are going to set up an alert based on the query that the AI generated. So we go in here, and you can see we copied the query from here into the alert. And now, if we save that, we will get alerted anytime there is an out-of-memory exception with our Spark system. I didn't have to create this query manually. The LLM did it for me. It actually probably knows the Spark system and the types of problems that can happen with Spark systems far better than I do, to be honest. And you can see that alert in Elastic over here. So we've done significant events now. We've found problems in our logs. We've also made a lot of other things much, much easier. It used to be kind of tricky to do in Elastic. We've made things like retention and data quality issues much easier to see using the Streams UI. So the next thing we're going to dig into is I'm going to show you how easy it is to do that now. So if you look in here, we can actually change the retention pretty easily. So, if I want to change it to 30 days, for example, for these particular Spark logs, I can change it very, very quickly in here. I can adjust the ILM policies. So if I want to just put, 2 days of hot and 30 days of warm, or maybe I want to use the frozen tier to save even more money on storage, I can do that quickly in Streams. We've just made these things a little easier to do, hiding a lot of the complexity behind the scenes. So we can set retention, and the other thing we can do is we can actually look at data quality. So if we look at the data quality, here. There's actually two types of data quality things that we could do. So if you think about data coming into Elastic, we can tell you if there is a problem with a particular field that's coming in, a specific piece of data, or we can tell you if the entire document failed to come into Elastic. And we store that information in our failure store so you can dissect it. So I'll show you how that works. Again, we've made it much, much easier to do all these things in streams. So the first thing I'm going to do is I'm going to deliberately break this regular expression. So you can see here I've put some nonsense in there. We're going to ignore failures for this processor, and we're going to update that. We're going to save the changes, and now what will happen is Elastic has caught the problem. If you see here, the entire document has failed because that regular expression is broken. So it failed to bring that document into Elastic successfully. And we can dig into what the problem is. So you can see here, it tells us straight away that the provided grok expression did not match the field value, which stopped the data from coming into Elastic properly. So it's much easier now to see when there are problems with the data stream. So that's one thing, that's the entire failed document. But we also can do it on a field level as well, right? So if we go back here, we'll, first of all, we'll fix this so it's not broken anymore. And then what we'll do is we will create a new processor. We will use the host name, and we'll put a ridiculously large host name for you. That is definitely not a host name that will fit any sort of validation logic that I'm aware of. So we'll do that, and then you can see what happens in the data quality pages. Now, instead of a failed document, I've got a degraded document. And that's because it's ignoring the hostname field. And if you look at the hostname field in here, it's because the size of the hostname is too big. So we basically just ignored that specific field. We're still ingesting the document, and we're still ingesting all the other data, all the other attributes that are in there. We're just ignoring the host name because that field's being corrupted. It's got a completely ineligible host name in it, right? So we'll go back and we'll fix these problems. We'll delete this. We'll save the changes. And then if we go back in, everything's working again now, right? So that's streams. Those are all the new goodies that we've released in Elastic. I'll switch back to the slides. Here we go. So you can see now why we need a good, solid platform. We need to scale to billions of logs and do that in a way that's cost effective. We want to simplify ingest, right? We don't want people to have to wrestle with pipelines and drop data on the floor. We want to automate as much of that as possible, and we now have AI that can really help us with this automation. And now you can spend more time solving problems instead of working on log processing pipelines, which I know is a massive headache for a lot of you. And we then use AI to do a lot of analytics work, to surface problems in your logs automatically, to give you the ability to, find problems, for example, that you may not even be aware of in your Spark logs, for example. And, at some point, our vision is to bring this beyond logs, right? Bring it to traces and metrics at some point in the future. So, thank you very much, everybody. Thanks for joining me on this talk about streams, and appreciate you coming all the way down here from the Venetian. Thank you very much.